Hello and welcome to video 3.2, adding the basic game logic. In this video, we're going to talk about how to implement the game logic into the existing stage which we've created in a previous section. If you recall, this is the way the stage looked in the previous section. We've added the bricks, we've added the ball, and we've added the pedal. Now, we wish to add the game logic into the game so that when the ball hits a brick, it will disappear, and so on and so forth. So let's take a look at the code. This is the code from the previous section. Now we're gonna add the required changes to make the logic work. So first of all, let's do some cleanup. In the previous section, we've created ball in a constant radius here. We've added the value 8. Since we're gonna need the ball radius for various calculations in order to determine the location of where the ball hit, we're gonna add it as a constant. So we're gonna create a constant here, call it ball radius, and we're gonna add the value 8, and we'll add it instead of the existing value 8. Next up, we've created the bricks variable, which is supposed to be an array. The array will hold all the bricks which are currently on stage. This way, when we test the location of the ball in comparison to the location of the bricks, we'll be able to loop over the bricks inside the array and find out where the ball hit exactly. So we're gonna initiate the bricks variable as an array. Let's take a look at the init function. We've configured it to have 60 frames per second, which means that there are 60 ticks per second in this command. Now, instead of using the stage as the source of these ticks, we're going to add a custom method, which we'll call tick, and we'll be able to determine what happens every time the ticker ticks. So instead of using the stage, we're going to add a custom function called tick. We're gonna add it here. In the previous configuration, when we had the ticks go to the stage would update every time it would get a tick. But now, since we're using a custom method, we need to do it manually. So we're gonna call the stage update method, which is required because otherwise the stage itself wouldn't update. The changes themselves would happen behind the scenes, but we wouldn't be able to see it visually on screen. Now we have some configurations we need to change in the ball itself. In the previous section, we've created a ball, we've added it visually to the stage, but now there are custom values we need to add to the ball object in order to be able to use them when we test the logic and the physics in the next sections. So we're gonna add a few things here. I've added 6 attributes. The attribute up will be used to determine whether the ball is going up or down. This will help us determine if the y speed, which is always a positive value, is supposed to go up the stage or down the stage. We added the custom value right, which will determine if the ball is going right. If it's false, then it's going left. And the same goes for the x speed. Since the x speed is always a positive value, we'll know according to the custom value right if it's supposed to go right or left. Now the last two values, last x and last y, will save the previous location of the ball. This will help us in finding out where exactly the ball hit, because whenever we'll detect that a ball hit a brick, we'll need to know what was the previous location to know where exactly the brick was hit. I'll explain more later. Now, in the create brick function, which we've created in the previous section, we've basically added all the bricks to the stage, and without having any references to them. But now, since we're using the game logic, we need to know exactly where each brick is placed and when a ball hit that brick. So, since we've created the bricks variable as an array, we're gonna add each brick we create to that array. So basically we're going to push that object into the bricks array. So now we return to the tick function which we've created. And since we have the custom variables in the ball, we can start working with them. So I'm going to test if ball is going up, then the ball y value will have the ball y speed value removed from it each tick. Because the y-axis basically starts from 0 at the top and goes down to higher values if the ball is going up. So basically we're removing a positive value from the y value of the ball to create the illusion of it going up. Now for the time being we'll do the same for the x value. We remove the same y speed value, which is currently 1, from the x value. This way we'll get a temporary movement so that we'll be able to see that the logic is working. And in the next sections we'll do specific logic for the x value.